The relevance and influence of self-similar avatars in educational settings has gained increasing attention, especially with recent advances in generative AI that allow for real-time customization of both appearance and voice. This work-in-progress project will introduce a novel approach by exploring how AI-generated visual and auditory self-similarity affects motivation, avatar identification, and engagement. Specifically, we want to test whether avatars that look and sound like the player can improve learning outcomes in an educational programming game. Our study is guided by 4 core hypotheses that will explore how self-similar avatars affect player experience and performance. First, we assume that high visual similarity will enhance motivation, identification, and performance. Second, high auditory similarity will do the same. Third, that combining both will produce the strongest effects. And fourth, these effects will be mediated by avatar identification. In addition, we include an exploratory research question. How do players subjectively evaluate the relevance and impact of self-similar versus generic avatars in gameplay? This will give us qualitative insights into how identity alignment is perceived beyond what we can capture through numbers. To test these hypotheses, we use a 2x2 between subjects design in a Java-based educational game called CodeBreakers. Participants will randomly assign to one of the 4 conditions: high or low visual and high or low auditory similarity. In high similarity conditions, avatars are generated from the participant's photo using Ready Player Me, and their voice is cloned with 11 labs. In low similarity conditions, we use a grayscale humanoid avatar and a human-like gender-neutral synthetic voice. All participants play the same set of puzzles, only their avatar identity differs. This design allows us to isolate how visual and vocal self-similarity impact engagement and learning outcomes. After a brief tutorial, participants will play CodeBreakers for 10 minutes while receiving feedback from their assigned avatar. We'll collect 3 types of data. First, performance metrics, including puzzles completed, hints used, and time spent. Second, self-reported measures using validated skills such as avatar identification from the player identification skill, motivation from the intrinsic motivation inventory, and competence from player experience of need satisfaction framework. Third, we include open-ended questions to capture how players perceived in the avatar's relevance and impact. These mixed methods help us connect behavioral, psychological, and experiential outcomes. This study is one of the first to examine multimodal avatar self-similarity across both appearance and voice, using generative AI in an educational game. By aligning avatars with learners' identity, we want to explore how this affects motivation, identification, and performance. Our findings will inform the design of future AI-powered learning environments that adapt to the individual, not just through content, but through representation. We hope this work sparks new directions in personalized educational technology and avatar research. Thank you.